Hi guys, this is Dr. Aeronautics, and this is tutorial 5, Orbiter Space Sim, titled Reaction Control Systems Basics. The first thing you're going to notice is we're actually in space now. It's a lovely morning here up at 296 kilometers, about 180 miles in altitude. The sun's just now come over the horizon a few minutes ago. And we're outside of the Mir space station, and we have our docking cone open so that we can perform a docking operation. So I'm going to demonstrate the basics of the reaction control system, which, by the way, is used for all maneuvers in space, for rotation, and for translation or moving about. It is used for strafing and moving up and down. Otherwise, the engines can take care of it. So we're going to get started now. And the whole principle on the reaction control system is that you can basically use Newton's third law. For every action, there is an equal and opposite reaction. And you might notice around here, there's these clusters of thrusters here. There's 4 on this thruster, and there's 4 on this thruster. And there's a couple over here. And then there should be some down here, but we can't see because it's the nighttime side of the ship. It's much easier to pick things out on the daytime side. Okay, here's one right there, and that would be another one right there. So we'll go back inside. And what we're going to do now to activate the reaction control system, we're going to turn RCS mode to translation. We're going to talk about translation first because it's easier to understand. So right-click twice for translation.
Rotation. Translation.
And the computer voice will call out the attitude mode that we do. So now we can demonstrate Newton's third law with operation. We'll get into the controls a little bit later, but I'm going to press a button that will make my thrusters shoot backwards. And because of Newton's third law, we should shoot forwards. And I'm actually going to come to this side so that we can see our speed relative to Mir. So I'm going to execute that maneuver in 3, 2, 1, now. And ending. So you can see now that we're moving. Let me try that again because you couldn't. It was very difficult to see the thrusters firing. There they are. They're in the back. That's why. So this is what we did. We thrusted this direction and we went that way. But this is space, which means there's no friction. So we're going to continue moving away from Mir unless we do something. And what we're going to do is have these guys right here fire, which will reverse the course and slow us down. So I'm going to execute now. And there they're firing, and we're moving the other direction, slowing down. And that's just about stopped us. So in space, you have to remember Newton's first law, which says that we won't move until we fire a jet, and then once we will, we'll accelerate until the jet is stopped, and then we'll move with the exact constant velocity. I'm going to demonstrate as we move back. We're going to move back at Mir with this constant velocity, and if we don't do something, we're just going to slip past it again. And we're going to continue moving until I create another maneuver, which is going to stop the craft and bring it to rest. Of course, this is relative to Mir. For you guys that know orbits out there, I mean, obviously, if we look down, we're moving at 8 kilometers per second or 17,000 miles per hour. Evident is that the clouds are moving, and are we over the Pacific Ocean? Let's see if we can get our surroundings by... Yeah, that's the Pacific Ocean, Rapa Nui. Okay, so we're back inside now, and I'm just going to... Oh yeah, that's right, we're still in motion. Okay, so it appeared as if we were going to crash into Mir, but we're actually going to slip under it. So we're getting close to it now. So I'm going to perform that Newton's third law maneuver, firing the engines, so that Newton's first law can be satisfied. We'll go back into rest by decelerating to a rest. And firing now. And stop. And I just did a little bit of adjustment there. You can see now we're at rest with Mir again. So with that, we can establish translation, which is the same as kinematics motion, which is often studied in high school physics. If you've done vectors, you know that everything can be described as having an x component, a y component, and a z component. If you were to imagine a house with a box has up, down, left, right, a ceiling which is up, a floor which is down, two walls which are to the left and to the right, and a wall which is in front of you and a wall which is behind you. We're going to call the left wall and right wall the x direction. And because number lines go up from right to left, we're going to call, and this is actually what it's called, this direction, moving away in this direction, is going to be the plus x, and this direction here is going to be the minus x towards the left. And then for the y, we're going to call the ceiling, we're going to call the plus y, because as you go up, your elevation increases. So the direction towards the star Acela would be plus y, and that means the other direction, straight down to the Pacific Ocean, is going to be r minus y. Note that this is not world-based. It's not absolute. It's sidereal, which means if we were facing another direction, whatever is under the craft is the minus y direction. And then the last two are the plus z and the minus z, because going forward is often described as gaining, like with your car. The direction in front, directly in front of the craft that we head in the direction, is going to be our plus z. And that means anything behind us is our minus z. So moving towards the horizon of the Earth here would be our minus z direction, and this would be our plus z direction, generally in the direction of Pisces and Venus, particularly right now. And luckily enough, the construction has a combination of x-facing, y-facing, and z-facing directions. You can see this one here faces an x direction along with this one here. And then these two here face the minus z. So we can control minus z, and then these ones here face the minus y. And there's more thrusters here, like this one here would also face the minus y direction. And because of these thrust clusters, we're able to control our movements. So we're going to demonstrate that now with Mir. Although I'm going to restart the video now because I don't want to... Okay, so now we have plenty of time to demonstrate this maneuver. So the way we're going to do this is by looking relative to Mir what our direction is. So the controls have up and down the y direction, 2 being up, 8 being down. This is the numpad, by the way. 6 is forward, which is plus z. Back is 9, which is minus z. And 1 and 3, 1 is left and 3 is right, is the x direction. And the left-right motion can be described as strafing. would be that. So we're going to do each of the ones in order. So I'm going to hit 1. We're going to strafe left plus X. So I'm holding that now. And we're now moving. We're now strafing to the left relative to mirror. It's a little bit confusing now because it's the other direction. But now you can see we're strafing left. Then I'm going to now strafe right by holding the 3 key, which will activate our plus X engines. And I'm doing that now. And we've stopped. And now we're reversing course. We're now going back to mirror. And so now I'm going to kill our motion again because we're going to keep moving like this pretty much forever. Okay, just wanted to confirm that was a light and not an engine that was still on. So I'm going to kill the motion now with the 1 key again because you have to do an equal and opposite force to kill your motion. And now we're going to demonstrate the Y direction, plus Y and minus Y. So I'm going to hold the 2 key, which will activate our plus Y engines, and we will move up now. So now you can see we are ascending like an elevator towards mirror. And I think in this case we will have to stop because we will get very close. If not, our engines might hit mirror, and the Russians would be very angry with us if we hit mirror. So don't want to do that. So to prevent that, I'm going to fire the minus Y engines with the 8 key and then move down again. So I'm going to fire those now. And you can see because of these engines on top here, we've now reversed our course and we're now falling relative to mirror. And to stop that, I'm going to hold the 2 key again, firing the up-facing plus Y engines. And now we're at a rest. So now we're going to demonstrate the 6 and 9 forward-back keys, which is the plus Z and minus Z direction. Also note that our engines here, our main engines, face the plus Z direction. So when we were taking off from the runway, we didn't know it, but we were actually thrusting in the plus Z direction. That's basically how that works. So I'm going to press the 6 key, which will fire these engines back here and shoot us forward towards the sun. And we will move forward relative to mirror. So I'm going to execute that burn now. And stop. So now you can see we're moving forward from mirror in the plus Z direction. And then I'm going to press the 9 key, which will accelerate us in the minus Z direction using these engines here, and we will move backward relative mirror. So we can actually reverse thrust using these, but they're not very efficient, so I wouldn't want to use those on the runway. There are other engines that we'll get to later that are used for braking and stuff. So I'm going to hold the Y key now. There go the engines. We've now killed our motion, and we're heading in the opposite direction. We are moving backwards relative to mirror and the minus Z direction. So that is all 6 movements, and I can now demonstrate these. I can now demonstrate these movements after I kill the minus Z velocity with a plus X, or a plus Z, sorry. I can now demonstrate all of these to you. A complex maneuver in which we will go all the way around mirror. We're going to start outside this module here, and we're going to go all the way around. I'm going to give voice callouts as to what we're doing, and then I'll also move the camera so that you can see multiple things, because it is 3-dimensional and it's very difficult to see a 2-dimensional maneuver. And I'm going to call out all the movements now. So to clear this, I'm going to press the 6 key. We now have plus Z. I'm going to press the 2 key. Now we're going to have plus Y. So now we're ascending. And I'm going to press the 3 key so that we get a little bit closer to mirror. And notice I'm not using any sort of instruments or anything. This is purely visually based. I'm not driving on any sort of display or anything. This is purely visual sight and knowledge of space mechanics. Okay, so now I'm going to stop ascending and we're going to move backward. 8 and 9 simultaneously. Done with 8, still holding 9. Okay, 9 is off. Okay, 9 is on again. 9 is off. And now we're moving behind mirror. And I'm going to switch to the inside sight so that you can see what it looks like as we move down across mirror, which will give you a nice dark tour of mirror, unfortunately, because it's the nighttime side of mirror. We should have done it opposite, because then you would get the daytime side tour. So I'm going to accelerate time at 10x occasionally, just to make this go a little bit faster. So 10x, 1x. Okay, I'm now going to hold 6. We're going to kill our velocity there. And now I'm going to hold 8, and we're going to start moving down across mirror. By the way, this is the docking MFD, or not the docking MFD, the docking HUD, which is a new thing to my videos. And so if we look down, there it is. We have this cross here. And remember, this cross represents the prograde velocity vector. So this is our motion relative to mirror. Okay, we're nearing the bottom now. So I'm going to hold 2 now. And now we're going to stop. And notice the prograde velocity vector is changing. I'm now going to take advantage of this. 1 second here. Okay. Do you see this minus V thing with the dot here? This is brand new to the videos. This is the retrograde velocity vector. This is the opposite direction we are moving in. And if I move it a bit here, remember what I said in the earlier video? Sometimes you are facing the opposite direction that you are moving. We're doing that right now. We're facing this direction, but you can see we're moving this direction. Oh, we're not over the Pacific Ocean anymore. If we're heading east, I'm going to guess that this is Chile crossing into Brazil. Don't recognize that city. Machu Picchu. Okay, so we're in Peru. Okay, getting on with it. Now you can see we've just reversed course. We're now facing the direction we're moving, and we're going to pass underneath Mir to give it a little bit of a boost. We're also going to add a little bit of downward. And you can see the X, the Y, and the Z. 1 second. The X, the Y, and the Z maneuvers can be used to face anything. So once we get around the other side with a little bit of time acceleration, okay, here's the other side. We're basically back where we started. Gonna give it a little bit of thrust, and we're gonna move back to our original position. That be the Amazon River. That's pretty cool. So you did this maneuver over the Amazon. Nice. Okay. It's quite cloudy down there. Okay, so I'm going to demonstrate this now. Something that we can see. I'm going to pick a target, and we're going to aim at the target. Let's see if the Pleiades are in view right now. No, they wouldn't be, because They might be. They could be down here. Oh, you hear that? That's our proximity radar. That's telling us, that's like a sonar call out. Okay, I'm going to aim for that. That's probably Mercury. Yes. That's basically telling me that I am not in the immediate vicinity, but a little bit of distance away from Mir. And the further we move away, the lower pitch that we'll get. And, you know, it's like the new cars will actually beep like a mine when you get close to something. Okay, so I'm now going to use a combination of X, Y, and Z engines to aim my prograde velocity vector at Mercury. And assuming there was no gravity, once we were aimed at Mercury, we would be moving in that direction forever. Boom. We're now heading directly towards Mercury, but of course gravity is going to be constantly eating at this, and this won't be the case. Okay, now we're going to, well, first I'm going to change my direction. We're going to move back towards Mir, because I want to shut this thing up. By the way, this here is in meters per second, which means we're moving 83 centimeters per second this direction. Okay, now as we get closer, you might notice the pitch change, and then eventually it's just going to chirp at us. And that's to warn us, hey, you're so freaking close, you're probably going to hit something. But you need to go a little bit closer for that. So I'm going to time X again, 10x, time acceleration 10x. You hear it pitching up. And there's the chirp. So we're a little bit closer now. I'm now going to move upward as well, so that we can move a little bit closer. So that's 10x again. And I'm fine with this distance. So this time we're going to kill our velocity using the indicator here. Okay. And we're now moving at 2 centimeters per second. We'll just call that stopped. Because we're in space, there's no friction, it's impossible to stop, but we can get very close to stopping. So now, we can move on to rotation. Ooh, it looks like we're at the mouth of the Amazon. Yep, that's it right there. And now we're going to move over the Atlantic Ocean. The tropical Atlantic Ocean. That's a new sight, because so far we've only seen North America, because we've never been in space before. It's possible the next tutorial might be on reaching orbit. No, that's on ballistics. Never mind. Almost. You'll be able to see a lot of things at one time. Okay, so rotation. We're going to left-click. Did I say left-click the first time? Because I meant right-click. No, we're now going to right-click this once to go back to rotation.
Rotation.
Okay, so now what we're going to do is we're going to use our jets here. We're going to fire one jet in one direction and another in the other direction. Let me see a good pair to demonstrate on. Okay, so this right here, we're going to fire this jet down, and we're going to fire, where's the other one? There's another jet up here that we're going to fire up. You might not be able to see it because it might be behind one of these. But I'm going to press the 2 key and watch what happens. All of a sudden we're spinning. And see, okay, there's the other one there. You can see that one is shooting down and this one's up. We're now spinning quite fast. We don't want to be spinning any faster, but I'm going to leave us here because it's somewhat hard to believe this is actually stable. So that basically demonstrated Newton's third law again, which basically says equal and opposite reaction. And once we're in motion, just like when we were stopped, we're staying in motion, torquing around, where is it? Let me see, 1 second. Okay, we're actually spinning in multiple directions now, thanks to torque. Okay, right there. That's our axis of spin, which is nutating apparently because I have to keep moving it. It's nutating that direction. Okay, so this time, imagine a circular shell around us. That shell would have an X, a Y, and a Z on it. So we can now rotate to everything as opposed to moving towards everything. Oh, that's interesting. So we can use the X, Y, and Z directions to face anything. So now the possible directions that we have, I'm going to go ahead and stop us now. Okay, so we've now stopped. So the possible directions that we can move, just like an airplane, are roll, pitch, and yaw. So the x-axis is going to be our roll axis. Roll can also be described as banking, movement around the roll axis. Plus x is going to be rotating towards right down. It's going to be confusing. Our right engine is going to be moving down. Minus x would be a roll left. That would be this moving down. And a roll left is executed with the 4 number pad key. We're now rolling left. And the roll right is executed with the 6 key. We're rolling right now in the other direction. So then I'm going to kill this off. And we're stopped again. And then the Y direction is described as pitch. And plus Y is pitch up, and minus Y is pitch down. Pitch up accomplished with the 2 key, pitch down the 8 key. Just like Flight Simulator, if you've ever done airplanes. This is just like it, except we now have to kill our motion. Unlike an airplane where friction will stop your movement, we actually have to kill. So that's a pitch up maneuver, and we're now moving. So I'm going to kill that with a pitch down engine fire, and now we're going to do a pitch down maneuver. And now I've just pitched up again to kill it. And the last thing is the Z, which is yaw left and yaw right. This is accomplished with the 1 and 3 keys on the numpad. 1 being a minus Z yaw left, and 3 being a plus Z roll right. So now I'm going to kill it off again. And because it's not perfect mounting, we actually torqued a different direction. I got to restart the video. Okay. Right, so we're going to actually demonstrate this. I'm just going to mess. I'm going to demonstrate this by facing the prograde direction of flight using a combination of X, Y, and Z directions. So I'm going to call that out as I face. So we're going to hit 3. So we're yawing right. Now I'm going to hold 2. We're also pitching up. 2 and 3 again. Get a little bit more. Okay, now we're going to hit 8 to level off the pitch. We're using this arrow to figure out where it is. 1 and 2. That's 1 again. There's 2. Sorry, 8, 2. 1, 8, 3, 3. And now I'm going to do whatever I need to stop it. And we're still rotating, so now we're going to use 6 to stop that. And you see, the shell that we face would have X and a Y, and the third Z is the direction we're actually facing. So that would be the orientation here that I'm changing. So you can see the spinning Earth above us. And I'm just going to stop that now. Wow, we're almost to North Africa now. And the sun will actually be setting soon, which is going to end it because we won't be able to see Mir anymore. And okay, so now we're going to turn 100% of the round, 100% around, which is, wait for it, the retrograde velocity vector, absolute opposite direction of flight. So I'm going to now use the 3 key, and we're going to rotate all the way around. Be careful though, because all the speed that you gain, you now have to lose when you roll around to the anti-grade velocity vector, just like that. You see I overshot because I forgot that the arrow points to the prograde. There we go. And I will explain to you what this kill rotation thing that you see is in just a moment. But that's interesting. Well, now we're going to face the prograde velocity vector. But we don't have to use one direction because I held 2. And now we're moving towards the prograde velocity vector. And we basically did a flip maneuver. And if I do this, it will right us again. So now the Earth is again facing down. Okay, so now we're going to demonstrate by facing a star. Let's see if we can figure out something to... Okay, here's Orion. I'm going to demonstrate this on Alnilam, the middle belt star right here. Right there. First of all, I need to figure out where it is. Okay, it's down there. So I'm going to face Alnilam. 3, 8, 3, 2, 1, 8, 2, 1, 8, 2, 3, 8, 8, 1. 3, 8, 1, 4, 3, 1. Okay, so you can see we're basically now facing Alnilam. It's pretty safe to say that. So now we've just rotated to anything on our sphere. Okay, so now I'm going to demonstrate to you the RCS autopilots. Remember how we're still relative to Mir, but we're still moving at 8 kilometers per second, well 7.9-ish, in somewhat this direction. We can actually tell the spacecraft to orient us in a certain direction that will allow us to face the direction we're heading. Useful if we wanted to make a rocket burn, because if you burn, you need to burn in the correct direction or else something could go wrong. Now the bottom is the daytime side of the ship, and here's the other engines here on the bottom. Okay, so I'm going to use that now. Prograde stands for prograde velocity vector. So if we press this button, the ship will do whatever it needs to do to turn towards the direction we're heading. So I'm going to hit that now. And it is now moving us and torquing us with a number of engines until it finds the direction we're heading. Which is telling me it's going to be this direction. Now if we look down, you can see indeed we are moving this direction because you can see the land is moving that way. So it did it properly. Oh wow, we're approaching sunset. You're gonna need to hurry up. And just like this, the retrograde autopilot will move us the exact opposite direction. I'm going to accelerate time so it doesn't take nearly as long. Phasing between 1 and 10x. And this is the absolute opposite direction we're going, because you can see we're moving this way and we're facing this way. Again, I said sometimes you face the opposite direction. If we were to burn here, then we'd slow down and crash into the Earth. That's just what would happen now. Right. Okay, so notice how the air has absolutely no effect on all the movements we did. It has no effect on the solar panels. We're still moving at the same speed. This is because our pressure is 0.00 Pascal. Almost undetectable. If you wanted to know the absolute pressure that we're actually experiencing, we can go to this. We're experiencing 1.77 times 10 to the minus 5 Pascal. That means 0.0001764 pascals of air pressure. That is space. It's a complete vacuum, and it's about one collision every 5 meters between particles. It's amazing how thin this is. So we are out of the atmosphere in terms of the air, but we're still highly under the influence of the Earth. These other autopilots here, orbit plus and orbit minus, will face us towards the north pole of our orbit and the south pole of our orbit. I'll explain that when we do orbital mechanics. And this level horizon will basically only rotate us in the direction that we're heading, so that the bottom of the ship faces level horizon, like we were flying like an airplane. And I'm actually going to use this when we do our ballistics. So we're facing the horizon now, like an airplane. But we're still moving the opposite direction for the most part that we're facing. And the hover hold altimeter is not related to the reaction control system. Okay, so that concludes this tutorial. I'm going to demonstrate a high-level advanced topic of docking of RCS operation by docking to mirror. There's actually a way to do this. I'm using the dock MFD, and it will show me where I need to go. And this is so complex, I'm not going to be able to use voice callouts. And I'll explain this operation later with a docking maneuver. But basically, I have to get 2 crosses, one for our translation or kinematic motion, and the other for our rotational motion. So I'm going to start doing that now. And you'll hear me switch between RCS rotation and translation multiple times. Okay, there's mirror. Okay. Right, so that's our thing, so we're going to want to go there. I'm actually going to fire the main engine.
10, 9, 8, ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff.
Translation.
And you can see what I'm doing based on the cross here, if you had a good understanding of this tutorial. Oh, that sucks. We're going to be darking under night. At least we have our docking lamp, because otherwise it'd be nearly impossible. I've tried to dock before to motherships with bays. This is fictional motherships with bays. And it's very difficult to do in a dark bay without a light. Although the newest updated version of the mothership has. There's our call out again. We're now going into night. Let's see where we are. It looks like we're over Libya right now.
Rotation.
Okay, so you can just watch this docking MFD do things as I move. I'm not going to explain it because it is pretty complex. Where's our... I'm looking for the rings that are supposed to be here. They seem to have disappeared for some reason. Oh, that's why we probably didn't we calibrated it because... Oh, okay, there they are.
Translation. Rotation.
This is a bit new to me because I have a docking procedure where I get out to the cubes and then advance from there. But it is kind of confusing because I'm not used to this kind of maneuvering. I don't think I explained the kill rotation yet. Basically, the kill rotation thing allows me to stop my rotations with the autopilot, making those movements.
Translation.
There it is. Oh, I guess this was the last one. I didn't think I was that close. Okay, I'm going to start moving towards Mir now. Although we could use our main engines here, I'm not going to because it's very
Rotation.
dangerous being this close. Let's just double check to make sure our nose cone is open so that, good.
Translation. Rotation.
And unfortunately, because of gravity gradients, we have to keep rotating.
Translation.
Okay, there's that chirp basically telling us that we're going to hit. In this case, we are going to hit, just at a very slow speed.
Rotation.
Okay, there's sunset. You can actually tell it's sunset because Mir's changing colors. Right before the sun sets, Mir will change to the sunset colors,
Translation.
yellow through orange and red. Yeah, the sun's going down right now. You can see the sky changing color.
Rotation. Translation. Rotation. Translation. Rotation. Translation.
You can see there's a heck of a lot of switching back and forth as we get really close.
Rotation. Translation.
With less gravity gradient, it's much easier to do.
Rotation.
Okay, I'm gonna
Translation.
slow down to contact speed, which is under 10
Rotation.
centimeters per second.
Translation. Rotation. Translation.
Okay, we should
Rotation.
contact
Translation.
very soon. There it is.
18 Houston, we show capture and hard dock. Congratulations.
Okay, so we've just docked with Mir. I don't think that was the welcome that I was expecting. But we're here. And we've demonstrated our reaction control system. And what do you know it? The sun just set. Is there any evidence of it on the horizon? Nope, it's long gone. Okay, and we must be over the Arabian Peninsula or something now. Yeah, that's probably... Yep, that's the Arabian Peninsula right here. Okay, so this has been Dr. Aeronautics Tutorial 5 with reaction control system. I hope you guys learned a lot from this episode and know how now to maneuver in space. Bye!